We can use the identities to solve a variety of problems. So I've put up this example. Let's suppose that theta is an angle in the first quadrant. In other words, it's somewhere between 0 and pi over 2, or between 0 degrees and 90 degrees. And that we know that the tangent of theta is equal to 3/5. Let's find sine of 2 theta. So what I can do here is as we did in an earlier problem, I can show a right triangle with an angle of theta. And we know that since the tangent of theta is 3/5, that means that the ratio of the opposite to the adjacent is 3/5, and I can just put in those numbers like that. So that means that the hypotenuse is going to be 3 squared is 9 plus 5 squared is 25, and that gives us a hypotenuse of square root of 34. So we now know that the sine of theta is equal to the opposite over the hypotenuse, and the cosine of theta is equal to the adjacent over the hypotenuse. Now, the question is to find the sine of 2 theta. Now, I know that some people sort of instinctively are going to write, oh, I know how to do that. Sine of 2 theta must be equal to 2 sine of theta, right? No, that's certainly not true, because it's not the case that all functions are linear. So the correct way to do it is to recall the identity from the previous screen, where we have sine of 2 theta is equal to 2 sine theta cosine theta, which is equal to 2 times 3 over root 34 times 5 over root 34, and that gives us 30 over root 34 times itself is 34, and that equals 15 over 17. So that's the sine of 2 theta.